Today we are measuring soil gas emissions, and we are using the Licor, I think it's the Licor 8100, and it can measure the amount of CO2 that's leaving the soil, and then you can collect samples to measure the amount of methane and nitrous oxide. So what you do is you open up the Licor requires a battery and a TP link to attach to Wi-Fi via Wi-Fi on the phone, and you actually run it from a smartphone. So to run this, you place a battery in it, plug it in, and then you take the TP link, which is right here, and it's turned off, so you turn it on right there. And then there's this where you can attach it between 3G-4G WISP and AP, and for some reason on my Motorola phone it likes the WISP. So then you take this and then you plug it in. You plug it in to right here and attach it to this port here. And then you turn this on. And you want this to sit for a few minutes before you start running, because it seems to give you a negative number for CO2, especially when it's cold out today. And right now it's I think like 38 degrees Fahrenheit, so like 3 degrees Celsius, so it's not very warm. I don't know how warm the soil is. I'm going to find out in a minute. And then it turns on and is warming up. So what you do, what's needed to collect soil gas emissions is a syringe to take volumes of gas out of the Licor and place into these sample tubes, and you need sample tubes here. You need 4 per plot, as we collect one every 5 minutes. So you can measure how much gas is being released over 5 minutes, and it's variable 5-minute intervals, and then use that to calculate the soil gas emissions. Then you need a 2x4 board to pound in the ring that you use to collect the volume of gas from, and then you need a sledgehammer to pound in the ring. You need a thermometer to measure soil temperature. You need a ring that the Licor is placed on, or other people create their own types of chambers that are airtight to collect soil gas emissions from also. This is probably more accurate, but people also will use barbecue pans or other airtight devices to calculate soil gas emissions from. And you need some type of soil ring or soil measurement technique to collect a certain volume of soil to determine the air-filled porosity and water content and bulk density. And you need a bag to put the sample in to go and oven dry after you're done sampling to determine what the water content is of the given volume of soil you've collected. And then you need a pen to write your soil temperature and how much CO2 is released on a notebook, which you also need. And then you need a Sharpie to label the bag, which plot it is, and the date and so forth that you collected the sample. So the first thing you do is you pound in the ring, and you want to find a place which isn't disturbed, and you want to remove some of the residue away from the surface, because the residue will make it not seal. It's important to have it sealed tight. So, and you want to go semi-close to where the rolls of the crops were. This soil is pretty dry, so it's going to go down. This plot won't go down. It'd be hard to pound in, but some of the other ones will. And you just want to gently tap it in as even as possible. And then around here you want to pinch down, press down the soil so it's sealed tight around the ring, so it looks like this. There's the cheap thing. So it looks like this around here. And then you're going to take the Licor and place the Licor top of the ring. And another item I forgot to mention that you need is a stopwatch. So I have a stopwatch here so you know what time your collecting samples are. And then you have this set up. And then you take your phone and you connect to the program that you download on Licor website. And for some reason it does not work when I have data on my phone. It's LI8100 is the app, the LI8100 app. So I don't even know if you can read this, but it says connect to instrument. And then on the inside here it says what your instrument number is, which is here. And then you enter that into your phone, and then you can save it and can hit connect. Connected, that's why, on my phone. Now it says it's connected, so I should be able to open the app. And connect. So what's the date today? 10/19. Well, this plot is 1, and it's 20 milligrams per hectare of biochar. So that's what treatment it is. This is probably the easiest one to sample here because it decreases the density of the soil. So it's nice and it's a lot easier to work with than some of these harder clayier treatments of the soils of clay loam. So then it's on, so I hit start on the stopwatch here, and then you take a syringe, and for the initial one, you take the sample right by where the ring is on the outside. And then you take the vial that's labeled to this measurement, which I just have a system I set up, and this is labeled 1. And then you take the sample, and you put it into the vial, and the vials are degapped before you sample, so you use a vacuum pump to degap. And because to collect the known given volume of soil, you take these rings, and you want to avoid putting these where there's been traffic in the field too. So I just have them set right here, and I just press them in here. And then you have other rings to set on top of it. And you want to keep these straight as possible. And sometimes it involves a sledgehammer to get them to go through. This one didn't. And then you use a garden shovel to dig these out. And you don't want the bottom to fall out of them, and you want to trim them so they're flush with a knife. These ones are flush without a knife, but put a knife in here. No. And then you place 2 of these into a bag, and then you determine what the volume of soil, what the water content is, what the air porosity is. So here's the second one, and you want to trim off this extra stuff on both sides. So then you have it flush right here. And then you take the Sharpie and label the bag, what sample it is. So I labeled the bag. This is biocharged black material that's made by burning materials, and it's supposedly like a stable form of organic matter, and it should behave similarly to organic matter that's been in that is in the soil for a long time, and we're trying to figure out how it affects soil properties. And it can be made from anything from wood chips to corn and wheat. My stopwatch is almost to 5 minutes. So at 5 minutes, there's a septa in there, and this is pulling gas through here. So the gas that's coming up from here is coming through here. So it's 5 minutes now, and then we take 25 mils of gas out of the chamber, and you wait till it's fully full to that and stops pulling in air, and then you take that and place this into the septa of your vial, the syringe needle, and then you place this into here, and then we measure how much N2O and nitrous oxide and methane and carbon dioxide. Take a thermometer here, and we place it in the soil an inch below the soil surface at a bunch of spots throughout the plot and record what the temperature is. So it's 37 degrees out. And this can vary widely. So like if I place this where there's residue, it says the temperature is 47.5 Fahrenheit, whereas if I place it where there's no residue, it's going to be cooler. Maybe not. It says 49.3 here. And I place it over here, and it's 47, 46 point. Anyways, this varies widely, so you usually measure it in 10 spots throughout the plot. And I haven't changed to Celsius. The residue slows how much the temperature changes by because it provides insulation. And water content will also help the soil retain heat. So where it's a little wetter and there's more residue, it'll be a little warmer than where it's bare and drier. So then I collect another sample and place it into the syringe at 10 minutes. And then what I usually do is I go to the next plot and take some of my equipment to the next plot that I don't need for the last 5 minutes. And then I pound in the ring. And then I'm going to find a spot where it's not disturbed and pound the ring. It should be right here. This has less of the material added in this pot also. I have no idea how this video should turn out. Maybe we should go close up. It's really dry. We also have cover crops we plant here. Here's a mixed cover crop, and here's some rye and field pea and radishes. And the other cover crop we're planting is rye only, which is right here. It's coming up really slow. It really needs some rain to get going though. Stopwatch is at 15 minutes. And then you pull another 25 milliliters of gas and place it in the correct vial that's been degassed, like this. And then you wait for the Licor to pull up and finish measuring, because it comes up once you're done. And now you click on here, which you probably can't see, but you click view. Actually, I should just take the cover off my phone and you might be able to see it. So you click on view down here, and then you click summary. And then your CO2 is on the bottom. So our CO2 flux is 1. And I don't recall the units off the top of my head of it, but that's about what I'd expect them to be, maybe even higher than I'd expect them to be today, because it's cold out and kind of dry. The gas emissions are highly dependent upon soil temperature and water content. So you're more likely to have higher oxide and methane emissions when it's warmer out and the soil is closer to saturation / lower percentages of pore space has air in it, and you're more likely to have CO2 when there's more biologic activity. Then N2O and methane are also dependent on biologic activity, but they need to have anaerobic conditions. You're going to have the highest CO2 emissions when you have a higher temperature and intermediate moisture contents, like 50%, 60% air-filled per water-filled pore space. And when you have plants growing, it tends to be a lot higher. So I'm just going to continue. So when we're done, collect these samples and come back to the lab. We take the bags of sample we collected. So this is the first plot what they showed for them. And then you place it in a tin. You record the weight of the sample and tin. So this is a sample 120. Tin 183. And this weighs 6.91 grams. And you pour the bag of wet soil, the entire bag, into the tin. And then you record the weight. This only weighs 77.61 grams. This material we got is really light, so that's why the weight's less. Then we dry it in the oven for 24 to 48 hours at 105 degrees Celsius. So now that I've weighed all these samples, I placed them in the oven set at 105 degrees C. Oh, that one's not at 1. That one's at 113. That's too hot. Anyways, this was set at 105. It just dropped down when I opened it up. And then placed them into the oven here. Measure the soil gases. We place them in these racks, and this rack has standards of certain concentrations, which creates a calibration curve. And then you place the vials in here, and then this needle goes down and extracts 2.5 milliliters of gas from the vial and places it into the gas chromatograph here. And then you read the data on the computer, and then you calculate the flux over time that you sampled the gases, and that's how you get your emissions of nitrous oxide and methane from the soil at a given time.